So after finishing this shear force diagram, you can mark it as parabolic. This is plus and this is minus. If you are putting this as plus, you have to put this as minus. So mark the ordinates WL by 3, this is WL by 6. So this X I have marked to find out where the shear force is becoming 0. That we will discuss later. Now we come to drawing the bending moment diagram. Bending moment at X I have again taken to the right hand side. So you have to take the moment of this much area of loading and this moment of this particular reaction. So first of all I have taken the reaction here WL by 6 into X. That is WL by 6 into X. This is an anti-clockwise moment or it is a sagging moment. So I have taken this as positive, right? Then what about this loading? This is going to give you a hogging moment. So this particular loading about this section XX, I have taken this much area of loading that is acting as the center of gravity of this much triangle. So I have marked here X by 3 here. So this is the area, this is a concentrated load being converted for this particular area, and that is acting at X by 3 from this section line. From here it is 2X by 3. So I have taken this particular area is half into Wx into X, right? Half into X into Wx, which I have already found out, Wx by L into this much is the loading into X by 3. We are taking moment about this section line, so it is into X by 3. So that finishes your equation, that is WL by 6 into X minus Wx cube by 3 into 2, 6L. So as per the equation, it is third degree equation, so it is cubic equation. Now you are going to find out the ordinates based on this equation. At X equal to 0, bending moment at B, this is 0, this is 0, so you are getting bending moment as 0. Then X equal to L, what happens? Bending moment at B is equal to WL square by 6 minus WL cube by 6L. So this L get cancelled here, so L square by 6, WL square by 6 minus WL square by 6, you are getting 0 value. So you are getting this particular point as 0 and this also as 0. But you know that this is a cubic equation, so you can get the shape based on the condition that where shear force is 0, bending moment is maximum. So this particular condition we have got from, if you recall your relationship between bending moment, shear force and rate of loading, we have said that rate of change of bending moment gives you the shear force, rate of change of shear force gives you the loading. So as per that particular condition, you are saying that for bending moment to be maximum, dm by dx has to be equal to 0. dm by dx is nothing but shear force, right? So you have to locate where the shear force is going to be 0. So you have to go back to your shear force equation. That is, I have written here, for bending moment to be maximum, shear force has to be 0, or shear force at X equation we have already written, you equate that to 0 and solve for the value of X. So you get this much distance is how much in terms of L. So then you back substitute in your equation for bending moment at X. This equation, you substitute this value of X in this particular equation. So you will get this value of magnitude of the maximum bending moment occurring. Okay. So I will just repeat once again. For writing the bending moment at this particular section, you have to look to the right hand side. For right hand side, you have got this much loading as well as this reaction component. So this reaction component into X, that is WL by 6 into X, which is a sagging moment. This is anti-clockwise, so it is sagging. So this downward loading is going to create a hogging moment. So it is minus half into area of this particular triangle gives you the total load. So that is half into X into Wx by L, which is acting at 1/3 of this particular triangle. So I have marked here 1/3 distance X from this particular section line. So this is the loading into moment distance. So you get your equation WL by 6 into X minus Wx cube by 6L. Since it is a third degree equation, it is cubic equation. So you have to understand that the variation has to be cubic. Now you substitute the limits X equal to 0 and X equal to L. You get the corresponding values as 0. So you get this as 0, this as 0. But that won't give you the correct picture of bending moment diagram. So in order to get the correct picture, you have to find out where is this maximum value coming. So for that, I am using the equation relationship connecting bending moment, shear force and rate of loading. So in that, you are getting dm by dx is equal to shear force as well as df by dx is equal to rate of loading. So you are going to say that for bending moment to be maximum, dm by dx is equal to 0, which you can recall from your differentiation you have studied in mathematics. So for bending moment to be maximum, dm by dx has to be maximum 0. Sorry. So dm by dx is nothing but shear force. So shear force has to be 0. So you have got your shear force equation. From there you solve for x. Substitute back in your equation for bending moment. You get the value of maximum bending moment. So please write down what is x, what is maximum bending moment. So you can finalize your BMD and SFT. Okay.